With any problem, the first step is to go through the question, taking down the essential details and making notes. So first of all, we know that we have a compound, magnesium hydroxide. We have its mass, so I'm going to make a note there that is the mass of the compound. And immediately, once we know that, we can convert that into number of moles. We have its formula, and we have a volume in dm cubed. And we've been told the magnesium hydroxide is fully dissociated into its ions. We've also been given an equilibrium constant expression for magnesium hydroxide, which gives us an idea of the equation we should be writing. So the first step is to look at the balanced equation for the dissociation of magnesium hydroxide into its ions. So if we write an equation, that's magnesium hydroxide, we're adding water to it, so for that we'll just put plus AQ, fully dissociating into 1 mole of magnesium 2 plus ions, AQ, and 2 moles of hydroxide ions, AQ. And that helps you to realise why the equilibrium expression is OH minus squared. So if we now write our equilibrium expression, K equals the concentration of magnesium ions multiplied by the concentration of hydroxide ions, and we square that because there are 2 moles formed. Notice the solid magnesium hydroxide does not appear in the expression, A, because it says it's fully dissociated, and B, because it's a solid and these two are aqueous. So it's nonsensical to have a solid in the equilibrium expression. If we now look at the question, the second part of the question, it tells us that the concentration of hydroxide ions is 1 times 10 to the minus 3 moles per dm cubed. Well, if we look at the balanced equation here, if we have 1.0 times 10 to the minus 3 moles of hydroxide ions, since the ratio is 1 magnesium to 2 hydroxides, it follows that the concentration of magnesium ions must be 0.5 times 10 to the minus 3 moles per dm cubed. Now we go to write our expression for K, and that's the concentration of magnesium ions, which is 0.5 times 10 to the minus 3 multiplied by the concentration of hydroxide ions squared, which is 1.0 times 10 to the minus 3 squared. The value of K, 10 to the minus 3 times 10 to the minus 3 squared, that's 10 to the minus 6. So that's 0.5 times 10 to the minus 10. 10 to the minus 10, or 5 times 10 to the minus 0.5 times 10 to the minus 9, or 5 times 10 to the minus 10. The units must be moles cubed to dm to the minus 9. Why? Because the concentration there is moles per dm cubed, and moles per dm cubed squared gives the units of moles. Cubed dm to the minus 9, and that corresponds to D. The red herring in this question was giving you the concentration of the magnesium hydroxide in 10 dm cubed. But what that actually does tell you is that magnesium hydroxide is sparingly soluble, hence a very, very small value for the equilibrium constant for this equation. So that tells you that magnesium hydroxide solution is very saturated at low concentrations.